So I was watching this video the other day, and it said that fusion can generate nearly 4 million times the amount of energy as fossil fuels for the same weight of fuel. So I was like, what? How is this possible? Well, turns out it's because of one of the most famous equations in all of physics, E equals mc squared. So basically, this equation is saying that there's an enormously large amount of energy contained in a very small amount of mass. And here's how it applies to fusion. A fusion reaction is basically deuterium plus tritium, which is two types of hydrogen, combining to form helium and a neutron. The thing is though, if you add up the masses of all of these, you actually find out that the products weigh 0.02 atomic mass units less. So what's happening here? This missing mass was actually released as energy because thanks to Einstein's equation, we know that energy and mass are equivalent. So using this equation, we can calculate the exact amount of energy that was released. Okay, so why is energy being released? Well, fusion basically lets us transition atoms from being slightly unstable to being more stable. When something is stable, that means it's unlikely to change quickly. So here's an example. If you had a mountain and you had a ball on top of that mountain, that ball would be pretty unstable because a slight nudge in either direction would cause it to roll all the way down to the bottom. But if you had a ball at the bottom of the mountain, that would be pretty stable because it's pretty hard for the ball to roll back up the mountain. In the context of atoms, iron-56 is the most stable. This is because it has the highest binding energy per particle inside of the nucleus. Binding energy is basically how tightly the particles inside the nucleus are held together. The higher the binding energy, the harder the nucleus is to break apart. The higher the binding energy, the lower down on the mountain. So fusion basically starts with two small atoms that are relatively high up on the mountain. They are relatively unstable because they have a low binding energy. But when we combine these two atoms, we can form a new atom that has a higher binding energy, and now it's lower down on the mountain. So it's this transition from high up on the mountain to lower down on the mountain that releases energy that we can then capture.